Hello, everyone, and thank you for joining today's Code Long. My name is Reese, and I'll be your moderator today. We're going to kick off the session in a couple of minutes. We're just waiting so everyone has a chance to join. In the meanwhile, though, we'd love to hear from you, so let us know where you're joining from using the chat or the comments, depending on what platform you're watching on. And yeah, tell us something that you'd like to get out of today's session. We are going to be using DataCamp Workspace today, so I'll be sharing a link so you can code along with us shortly. So keep your eyes peeled for that in the chat. One thing I'd also recommend you do is register for the event so that we can send you the recording of today's session, as well as any other resources that we've got. So you can scan the QR code on screen now. I'll also be sharing a link to that in the chat very shortly. So yeah, keep your eyes peeled for that. Brilliant. I think that's everything from me for the moment. So I will be back to repeat these messages for any new joiners shortly. But until then, yeah, enjoy the background music. Hello, everyone, and thank you for joining today's Code Long. My name is Reese, and I'll be your moderator today. We're going to kick off today's session in about a minute or so. We're just waiting so everyone has a chance to join. In the meanwhile, though, we'd love to hear from you, so let us know where you're joining from using the chat, the comments, and yeah, tell us something that you'd like to get out of today's session. If you haven't done already, make sure you register for the event today. The QR code is on screen, so you can scan that, or you can head to datacamp.com/webinars, or you can find the link that I've put in the chat. I'll be posting it again shortly. And then that way we can send you the recording so you can code along in your own time as well. And we'll also send you all of the resources for today's session as well. We are going to be using DataCamp Workspace today. So if you don't have a DataCamp account, then now's your time to get one set up. You won't need a paid account to code along with us. Everything's free on Workspace if you code along with us today. So yeah, keep your eyes peeled for the link that I'll be sharing in the chat, and you can code along with us. I'll also be posting a link to the slides that we'll be running through and a few other resources. So yeah, keep your eyes peeled in the chat for the stuff that I send through. Also, at any point, if you have any questions throughout the session, then please let us know using the chat or the comments, and I'll be saving them for the Q&A. We generally tend to do the Q&A at the end, but we may have stop for a Q&A if we're getting lots of questions midway through. Brilliant. I think that's everything from me. So I'll now hand you over to your host for today's session, Richie. Richie, please take it away.
Hi there, data scamps and data champs. This is Richie. Now, one of the big problems with generative AI is that it can lie to you. So these so-called hallucinations can be especially misleading because these generative AIs like GPT can sound very convincing when they talk nonsense to you. And so that means that you need to be skeptical about the outputs from these large language models. Of course, it's a bit of a problem if the text is being generated in a customer-facing scenario, like you've created a chatbot or something, and then you have to assume that your customers are going to be skeptical. So very, very tricky. A better solution, rather than enforcing skepticism on everyone in the world, is to evaluate the quality of the output from your large language model. So that's what we're going to be covering today. How do you test, are these outputs any good or not? Our instructor is Josh Riney. He's a developer relations engineer and a data scientist at TruEra. He's responsible for education initiatives and nurturing a community of AI quality practitioners. Josh is also a core contributor to the open source TruLens software. And prior to TruEra, Josh used to deliver data and machine learning solutions to the Department of State and other government organizations as a consultant at Deloitte. All right, so over to you, Josh. Please take it away.
Awesome. Thanks, Richie. And thanks, Reese. Really excited to be here with the DataCamp team. So in today's talk, I'll be talking about how to programmatically evaluate large language model applications and their responses. So in the case study in the code along today, the data we're going to use is an insurance handbook from the Insurance Information Institute. And our primary goal is going to be to build and evaluate a retrieval augmented question answering application, or a RAG, that doesn't hallucinate. Our secondary goal is going to also ensure this app is responding in a harmless way. And this is super important because moving LLM apps from dev to prod requires our application is honest, harmless, and helpful, and be free from hallucination. So if we think about the typical architecture of a RAG, which is what we're aiming to build, we're going to start with our user inputted question, and then we'll generate embeddings from that question and take those embeddings or those vectors over to our vector database and search for the top K most similar chunks that we will then pass back to our large language model in its context string. And the LLM will then use that context to form its final response. But these RAGs can hallucinate too. So here we built a basic RAG on the Trero website, and we asked it, who is Shayak? Shayak being one of our co-founders. The application responded correctly in some ways. So it said Shayak is a computer scientist, obtained his PhD from CMU, but then also hallucinated this piece at the end where it said he's a member of the Bank of England's AI Public-Private Forum and the OECD Global Partnership on AI. This, in fact, was instead about another member of our team named Shamik. And what likely happened is that we retrieved both information about Shayak and Shamik due to the way that information was tokenized, and then passed both those back to the LLM, and the LLM combined the two and formed this hallucinatory answer. And this is one of the core problems we built TruLens for. So TruLens is an open source project to track and evaluate large language model experiments. And once you've built your LLM app, you can connect it to TruLens to start logging the records, including inputs, outputs, and metadata. And then we'll define and add feedback functions to evaluate the quality each time the application runs. And this allows us to explore the records and evaluation results and compare versions of our app to identify failure modes and iterate to improve and find the best, most performant version of our application. So if we think about some of the core evaluations we need to do in a RAG context, we can think about each component of a RAG as a node. Between the query component and the context, we can do what's called a context relevance. In other words, this is measuring the quality of our retrieval. Next, between our final LLM response and the context, we can measure how the response is supported by that context. Is it hallucinating, or is it only using the information that it has given? And then last, once we've gotten to our response, we can compare it to that original question and ask, is the answer relevant to our query? These are some of the core evaluations that we're going to do in our code along today. In addition to these core kind of honest evaluations for the RAG triad, there's a whole bunch more evaluations that are out of the box with TruLens, some of which we'll also do today, such as those in the harmless category. At its core, feedback functions or evaluations are just a way to programmatically provide a score, reviewing an LLM app's inputs, outputs, intermediate results, and metadata. And TruLens has broad support for LLM apps like RAGs, agents, fine-tuning experiments, and we can integrate with frameworks like LlamaIndex, LangChain, or even custom kind of roll your own applications. And with that, I'll jump over to the code along. And if you want to scan this QR code right here, you can check out our GitHub and check it out. That way it gives us a star. We always really appreciate that. So here I'll switch windows, and I think Reese has posted the Code Along workspace link. So you can all open up that, and you'll start with this notebook.ipynb. So I'll give everyone kind of 5 seconds right there, and then we'll move on and get started with the Code Along. So in this Code Along, we'll go through a few different walkthroughs. So if you'll note, the notebooks that are appended with the to fill are the ones we're going to go through, and then the ones without that to fill are going to be the answer keys. So feel free to use the answer keys as reference later, and then let's start with the first notebook, one RAG prototype to fill. And then as we get started and set up our workspace, we're going to also need to do a few things. So the first one is going to be, we need to set our environmental variables. In this case, you'll need both an OpenAI key and a Hugging Face API key at various points in the workshop. So to do so, you're going to click on that plus button over here, and then add OpenAI API key, and then set a value. And then also the Hugging Face API key and set a value. Then you'll click this create button, and after setting its a set name for this environmental variables, and then once we've done so, we'll see it over here on the left, and we can just right click on these three dots and hit connect. Awesome. And then our session will connect in just a few seconds, and you'll see it's ready with this green dot over in session details. And then now we can go back to our files, and we can start with our installing a few packages that we'll need. So in this Code Along, we're going to use TruLens for evaluating large.
The text size of it there.
Oh, yep.
Yeah. All right, super. Thank you.
So in this Code Along, we're going to use TruLens for evaluating applications. We're going to use Llama Index as our core framework for building our RAG. And then we'll use Llama Hub and HTML to text to kind of do some of the loading and pre-processing, along with LLM Sherpa. And then we'll also need some kind of auxiliary packages such as Tenacity and Protobuf here. So we can just run this cell. So if everyone does this, this will take maybe a minute or so just to install the packages you'll need throughout the workspace. And then we'll only do this once, and then we'll be good to go. So as this loads up, I'll just scroll down a little bit. So once this runs, we'll just need to restart the kernel, and then we can import TruLens eval, and this true, and set up our true object, which is going to initialize our database. So let's see, now that our packages have installed, we can go up and hit this run tab and then restart the kernel, just to make sure our packages are good to go. Then now we should be good to go. So now we can import our true object from TruLens eval, and then set true equals true. And we can also pass this database redact keys so that we don't store any of our secret keys in our database. And you'll notice once I've done so, you can see, we'll see a default.SQLite later over here in the files tab. Great. So now that I've initialized our database, we can start by loading our data. So here we're going to use a smart PDF loader available from Llama Hub. And then we're going to point it to our insurance handbook available on iii.org. We can give that a few seconds to load. Great. And then now we can move forward with setting up our RAG. So the first thing that's useful to do is choose the large language model that we're going to use in our RAG. So here we'll import from Llama Index, and we'll use OpenAI. And then we can initialize our LLM. So we'll do LLM equals OpenAI. And then we can choose a model. Let's do GPT 3.5 Turbo. And we can also set a temperature. Let's do temperature equals 0 because we really care about making sure our application responds honestly. There we go. And then, now that we've set up our LLM, the next thing we want to do is set up our knowledge store. So here we're going to import a document from Llama Index. Then we'll set document equals document. And then what we're going to do here is we're going to join all of the different pages in the documents PDF that we loaded just 2 cells above. So we'll do text equals, and then we'll do the page divider dot join, and then we'll just loop through all of the different pages for doc in documents. Great. So now that we've done so, the next thing we need to do is set our service context. And so we'll again import from Llama Index. And then we can set our service context. We'll set it from defaults, and then we'll set the LLM equals the LLM that we set up just the cell before. And we'll also set our embed model. In this case, we're going to use this local BGE model as our embedding. So here it's going to be local :BAAI / BGE -small -n or English -B 1.5. Next, we'll create our index. We're going to use a vector store index. So this is going to be a lot like your typical vector database, but it's going to be in memory. So we'll set index equals vector store index dot from documents, and then we'll use the document that we set up above in line 2, and we'll set the service context with the large language model selection and the embedding model already selected. And then the last 2 things we need to do is to set up our system prompt. So here we'll set up a typical RAG-based system prompt that allows you to pass in the context string to our LLM. So we'll just say from Llama Index import prompt, and then we'll do system prompt equals prompt, and then we can fill in a string. So let's say something like we have provided some context information below that you may use. Let's add a divider to help the LLM understand where the context string is. And then we'll pass a context string here. We'll insert another divider. And then we'll say, please answer the question along with this query string. And then let's get rid of that stray quote. And then last, we'll set up our query engine using the index and then the system prompt. So we can do rag basic equals index dot as query engine text QA template equals system prompt. Let's run this cell. We had a misspelling slightly. Let's see if we can find the join. There we are.
Line.
Yep.
I think you've got a typo in the small thing for your embed model as well.
Gotcha. Typos are fun.
And you need some commas in the prompt. Is it multiple arguments?
No, prompt is good to go.
Okay.
Yep, there we go. So now we're setting up our query engine. So this will just take a few seconds, and then we can start writing our test set while we do so. Typically, when you're setting up a prototype, your first prototype of a large language model application, there's going to be a few core questions that you really want to get right. So this is what we'll write here. So let's write a few kind of prompts that we'll use to test our initial version. So let's say something like, what are the typical coverage options for homeowners insurance? And feel free to write your own questions in here too. I think it's really useful to understand the type of prompts you want to use to test, and there might be different things you might want to test for too. So feel free to write your own. I'm just going to write a few here. The requirements for long-term care insurance to start. We'll ask about fraud. Let's say, how much in losses does fraud count for in property and casualty insurance? And then let's say, what was the most costly earthquake in U.S. history for insurers? We can start with that honest evals set of prompts for now. Then we'll set that as a list of prompts. Then we can move on and set up our evaluation. So in TruLens, TruLens allows you to set up this extensible framework called a feedback function. So that's what we're going to do here. So the first thing we need to do is import the feedback module from TruLens. And then we'll also be able to choose a LLM provider, such as OpenAI, to run these feedback functions. So that's what we've done here. And then we can instantiate this OpenAI provider. And we could also pass like a different model. Say we wanted to use GPT-4 or something, but here we'll use GPT-3.5 by default. So the first feedback function we want to do is kind of that first edge of the node we talked about, which is answer relevance. So here, the first thing we need to do is use our feedback constructor. And then we'll pass in the provider, so OpenAI, and then the name of the feedback function we want to use. So we'll do relevance with chain of thought reasons. And what this chain of thought reasons is going to allow us to do is for the LLM that does the evaluation to also include this kind of human reasoning that justifies why a particular score was given. We can also pass in a human and readable name. So this can be whatever string you want, but let's call it answer relevance. And then the last thing we need to do is we need to point in our application to what text we want to evaluate this feedback function on. And this is because depending on how you set up your app, these texts can be located in a variety of different places in the application. But here, this is going to be just a simple kind of prompt and response. So we can use this helper function on the input output. Great. And then we can just close our parentheses. And then that should be good to go. I think I'm missing one. Oh, here we are. Let's put a nice parentheses kind of overall the whole function to help with that. And then we can move on to our context relevance. So context relevance is going to be very similar. The key difference is we're going to, instead of pointing to the output, here we're going to point to the context. So what this, you can think about this as meaning we want to look at each piece of context that we're retrieving and then measure how relevant it is to the user's query. So again, we'll do the feedback constructor, feedback, OpenAI dot, in this case, we'll do QS relevance or question statement relevance. And then we'll give it a name, context relevance. And then we'll do on input. And then here we need to point to the context. So here you see we imported TruLlama, and TruLlama is going to help us point to where the context is located in a Llama index app, which is the style of or the framework of RAG we're using. So we'll do TruLlama dot select source nodes dot node dot text dot collect. And then once we've done so, the last thing we need to do is, because we're going to measure the relevance of multiple pieces of context, we need to set an aggregation. So here we're just going to take the mean. Awesome. So here we've set up our LLM-based context relevance. And then it's also sometimes useful to measure the embedding distance. So this is just another way to think about the relevancy of your context. And this is going to be a lot closer to how your application is actually choosing which pieces of context to retrieve. So here, we'll just set a model name. Let's use text embedding ADA. And then we can set our embedding. So here, we'll just use embeddings. And then choose embed model equals embed model. And then we'll create our embedding distance feedback functions. So it's going to be a lot like we just did before. Feedback dot with embed dot, we'll take the cosine distance as our measurement or our metric. Dot input. And then let's copy the same context selector that we just did. So this on TruLlama dot select source nodes, and I'll correct a typo that I just see right now. And then the last feedback function we need to do is our groundedness. So this is going to be really similar to what we just did. So I'm going to copy and paste that into here just for the sake of time. So here we're passing the groundedness provider, the name of the feedback function, a human readable name, the context, the output, and then an aggregator. And then once we've done so, we can set up the list of feedback functions we just defined. So now we can run this cell, and let's see where I made a typo here, line 8. Not exactly sure why this is giving me an issue.
I think you've got an open
Let me just
parenthesis
copy paste this
US
in.
relevance that isn't closed on line 17. Is that right?
Gotcha. I can just copy and paste some untypoed code so we don't spend too much time on this.
Okay.
Great.
Actually, yeah. Hopefully that'll work. But I think, yeah, you were just missing a closing parenthesis on line 20 or something.
Got it. Yeah, that's the fun of typing live. Gotta love the code along. Okay, awesome. So here we've set up our list of feedback functions, and then the last thing we'll need to do is set up our true recorder. So here we're passing our basic RAG as the first argument into TruLlama. We can give it an app ID name to allow us to differentiate the different versions of our app, and then we can pass it in our list of feedbacks. So here, that's what we just did. And then we can run our evaluation on our sample questions. So we'll use our true recorder as a context manager. So we'll do true recorder RAG basic as recording. And then we can do for question, and we can just do a for loop through our different prompts. Response equals RAG basic query, and then pass in the question. So you'll note that we're using just the original RAG basic, and then we're just recording and evaluating each time it runs. So we can run this. And then here we'll just loop through each of the different questions. And then once we've done so, we can call our get leaderboard to look at the results of the evaluations. So we can do true.getLeaderboard, and we'll kind of type this out while the evaluations and records run. We can set our app IDs. So here we'll just want to look at this same app ID we just set up. So we'll copy and paste that app ID name. And then now we can run true.getLeaderboard, and we can see the results of our application. So here you can see we have pretty low groundedness. So all these metrics are going to be on a scale of 0 to 1. And so groundedness is hovering at about 1/3. Cosine relevance is about 0.15, which may not mean too much, but it's still useful to compare later. And then context relevance is also pretty low at 0.55. So if we think about kind of two key problems here, we're seeing is that we're retrieving poor context to pass to our LLM, and then the LLM is kind of hallucinating on top of that context. We can also see a few other metrics like latency and cost for our evaluation so far. So now if we go over to the Files tab, and then we're going to look to solve some of these issues. So here we'll move to honest rag to fill.
Oh, just
And then
since we're sort of halfway through, it might be worth taking a very short break to let people catch up. Now, if anyone in the audience has a question for Josh, please do ask now. I actually just have one question about the previous notebook, because there were quite a few steps in that last file. So can you just go through and just reiterate like what those steps we did were when you were doing the setting the evaluation?
Yeah, definitely. So when we think about setting up the evaluation, there's going to be kind of three key things we need to do. So the first one is going to be set up to set the model provider. So this is going to be the LLM or the whatever kind of model we choose to use. That's going to be the backend provider, or how we run the feedback function. The second thing we need to do is set the name of the feedback function, or the specific feedback function we want to use. So this could be relevance with chain of thought reasons. This could be cosine distance. It could be kind of a number of different things depending on what evaluation we want to do. And then the last thing we want to do is we need to point to which parts of our application we want to evaluate. So that could be the input and the output, or the prompt and the response, but it could also be include the context, like we did here with dot on select source nodes. So it could be a range of different things there, but those are kind of the three key components: is deciding the model we want to run our evaluations on, choosing the evaluations we want to do, and then pointing to the text that we want to run those evaluations against.
Excellent. And then when it comes to evaluation, can you just talk me through again, like exactly where that score was? So you had like those different metrics, and how, can you just talk me through like how those were calculated then?
Yeah, sure. So if we think about how we set them up above here, what we're doing if we think about this like answer relevance, what we've done is the relevance with chain of thought reasonings is going to be some kind of careful LLM prompting to pass both the input and the output, along with some kind of prompt, something like evaluate how relevant this response is to the user's question to an LLM. And then that LLM is going to output a score along with some justification on why that record scored low or high. So that's kind of the mechanism of how the score is provided, and then that's going to be calculated for, or generated for each record, and then we'll just aggregate across the records to get the average score for the application shown in the leaderboard.
All right, nice. And would you always want to use another LLM to evaluate the responses from the LLM? Is it always going to be AI monitoring AI, or would you ever want like a human to do that instead?
So it's useful. There's kind of a range of different things you can do as far as evaluations. So human evaluations are really expensive, but they're also kind of really informative. So especially in the early kind of prototyping, you might do something like a ground truth evaluation, where you set the exact responses that you want your LM to give, and then you automatically grade how similar the LM responses are to those responses, to those kind of ground truth responses. And then from there, once you start to get in the hands of users, you can do things like asking them to do maybe like a thumbs up, thumbs down, like OpenAI has, or even asking them for kind of text-based responses. And then as you start to really scale, you need to start to bring in some more kind of model-based feedback functions. So things like LLM-based evaluations, like we showed, things like cosine distance, and also things like using smaller models. So this could be models like BERT, or classification models, things like that can also provide that automatic evaluation on the records.
That's really interesting. So something like GPT-4, for example, it generally gives good answers, but it's quite expensive relative to others. So you might want to use small model in production and have GPT-4 check it. That's interesting. Okay. All right. That's enough questions from me for now. So do you want to go on to the next notebook? Thank you.
Yeah, definitely. Yeah. So in the second notebook, we're going to look to solve some of the key issues that we saw before. So here we're just going to run through a lot of these cells are going to be the same as before. So I'll just kind of click and run them. So we're setting up some evaluation questions, loading our data, setting up our evaluation. And then next we'll get to kind of a key change we're going to make. So in our first version of our RAG, we just did a pretty basic setup where we're querying our vector store, retrieving that context, and then passing it back to the LLM. But then here, we're going to use something slightly different called the sentence windowing approach. So here, what we're going to do instead is we're going to go to our vector store, retrieve a narrower piece of, more targeted piece of context, and then also expand to include 5 sentences before and after that context. And this is going to allow us to get a much more complete response than we would otherwise. So here you can take a look at the setup we're doing here. We're importing a few additional things. So you can see we're importing sentence window node parser from llama index. Also some post processors. We're setting the same system prompt that we did before. And then one thing we'll need to do is we can pass in our embed model. Sorry, just one second. So here we want to set our default embedding model to be the same as we did before. So it's going to be this local BAAI dot slash BGE small. And then we'll also do some caching here. So the sentence windowing takes a bit of time to create. So we want to include this save directory, and this is just going to cache it so that when we use it later, we can just run it the one time. So here you can see we're setting window size equal to 3. So that's going to be, in this case, rather than 5, we'll include 3 sentences before and after that targeted piece of context. And then we'll also set our LLM. So our LLM embed model and node parsers. So here we'll actually kind of fill these in later. So here we have our LLM or embed model, and then node parser. And node parser is going to be kind of how we're doing that sentence windowing. So if I scroll down a little bit, so before we created this build sentence window index, so that's like the index is kind of the first step of building any RAG, and then once you do that, you need to get the query engine on top that sits on top of that index. So here we'll set up a couple defaults. So we'll set our similarity top k equals to 6, and then we'll set re-rank top n equals to 2. So what this means is that when we go out to retrieve a set of context from our vector store, we're going to retrieve 6, and then we're going to re-rank according to some re-ranking model, in this case BGE re-ranker base, and then we'll only actually pass the top 2 to our LLM. So this is going to help a lot with retrieving helpful context. So now that we've kind of done that, we've set up our new sentence window engine. We'll pass in the system prompt to create the engine. And then we'll pass that to the same kind of true recorder setup we did before. So here we have true recorder RAG sentence window equals true llama, which is the TruLens and llama integration. We'll pass in our application, give it a new app ID, and then also give it the list of feedbacks. So let's see what we ran already. So let's run this cell. And this will take a few seconds to build our index. And then once we've done so, we can kind of proceed with running our set of prompts through this new improved version of the application. And then we can get the leaderboard to see how much better our application is doing compared to the first version. Let's see if we've finished running. It looks like we have. So now we can start running our prompts through this application. And TruLens is going to be recording each record along the way and then kicking off evaluations. So we'll just wait a few seconds. This will take a bit longer than it did the first time, just because now we have 10 prompts that we're testing with instead of the 4 that we hand wrote last time. There we go. Okay, so now we can get the leaderboard. Awesome. So now if we look at the leaderboard, we can really easily compare the 2 different application versions alongside or using these metrics that we set up. So here you can see our groundedness improved from 0.43 all the way to 1. And our context relevance also improved from 0.55 to 0.68. And it did this at even a lower cost because we're only passing that top 2 set of context, or those re-ranked set of context to our LLM. So the LLM has to use a lot less tokens, and therefore you incur less cost. I can take some questions here if there are any in the audience, and then we can kind of go on to the last piece.
There is just one thing from Edward. So Edward is saying that typing this code is causing his kernel to restart. I was wondering if you can see a problem with this. I think that's supposed to be 2 lines, so it should be from llama index import vector store index, and then the next line is index equals that. So
yeah, I can
spacing, but otherwise I don't know whether you've seen any problems with that line of code.
Yeah, it looks like it should be 2 lines. I agree. So it was the vector store creation.
Yeah, index equals vector store index dot from documents.
Let's see. I think it's probably easier to show in the first one. So let's go to the RAG prototype. Yeah, so here you can see it's 2 lines. So we'll do the import vector store index, and then we'll do index equals vector store. So this is what your code should look like. And you should have the kind of answer key over here in this RAG prototype notebook without that to fill appendix also. So that should help there.
Yeah, so good solution there. If you do have any problems with the code, try running the solution. If that works for you, then it's probably a problem with your initial code. So just see if you've what you've written is different to the solution. And if the solution doesn't work, then we've all got problems.
Cool. Oh,
all
yeah.
Right.
Yeah, I see it in the chat. So you just need to put enter after import vector store index, and then you should be good to go.
All right, super. And one question from the archaic revival. Can you show us the evaluation prompt so we understand how the scores are calculated?
I don't have those pulled up at the moment, but it's all open source, so I can maybe we could share some of those materials after the session.
All right, super. Let's continue.
Okay, awesome. So now that we've kind of constructed and improved the honesty or the reduced the hallucination of our app, then we can kind of move on to this sort of harmless evaluations. So here we'll go on to the third notebook, Harmless Eval to Fill. And then again, we're going to set up a lot of the same stuff we did before. So we're going to load our data, set some prompts. And note that we're going to use a couple different prompts than we did before. So here I've already pre-written some jailbreaking prompts. And this is going to typically go past OpenAI's usual model refusal and allow us to kind of make sure that we're protecting against these jailbreak prompts as well. And then we'll set up our harmless. We're going to fill this in. So I'll just walk you through a few of these setups. So one feedback function we'll use here is criminality. So to do so, we'll use our feedback class. And then we'll do provider, which is our OpenAI provider, criminality with chain of thought reasons. We can give it a name like criminality. We can do this higher is better equals false. And that's just because, well, before we always wanted a more relevant score. It can be, in this case, we want a more criminal score to be bad. And this will show in kind of a more UX leaderboard, which we're not showing today, is it'll show with kind of a red, like a warning signal. So here we'll do higher is better equals false. And then we'll do, in this case, we'll just evaluate on the output. So rather than evaluating both on the input and the output like we did before, or maybe on the context and output, here we just want to know, is the output of our LLM criminal? And then the second thing we want to do is this hate feedback function. So while the first one was using an LLM to provide the metric generation, here we're going to use OpenAI's built-in moderation function. So these are more kind of a classification model. So here we'll do f hate equals feedback. And then we'll do provider dot moderation hate. And then we'll give it a name. So name equals hate. We'll do higher is better equals false. And then just like we did a second ago, we'll do on output. And let's put this all in one parentheses. So now we've set up all of our feedback functions, and then we'll pass them into list to this harmless feedbacks list. And then we'll set up the same sentence window engine as we did before, so we can just run this cell. And you'll see we're passing a new app ID. So here we're doing sentence window rag dash harmless eval. So this is just going to allow us to separate the results of this harmless evaluation. And then we're also going to pass in our new list of feedback functions called harmless feedbacks. So once this setups, and this should be, yep, that's already done because we were able to cache it from before. Then we can run it on our new set of safety prompts. again, using our true recorder as a context manager to log and evaluate each time the sentence window engine runs a query. Then once this runs, we can just get the leaderboard to view the results. There we go. So here we can see the results of this evaluation. So we got a pretty high criminality score, which is something we'd want to avoid. Same thing for insensitivity, violence. There's a whole bunch of kind of unsafe responses that are coming out here. So let's try to improve this. Let's add a guarding system to the prompt to protect against jailbreaks that are causing this performance. So if we go over to the for harmless rag to fill, we're going to set up a lot of the same stuff we just did. So loading the data again, building our sentence window index. And then here we'll just add in our safe prompting. So here, this prompt is going to be mostly the same, but instead, we're also going to add this additional line. And this is going to help the LLM understand that it's trying to be jailbroken and help it know when to do model refusal. So here we'll write be especially certain to not respond in ways that could be interpreted as criminal, even in hypothetical scenarios and stories. And this is because the structure of the jailbreak that's being used here uses this kind of hypothetical scenario or like story-based setup. So now we can run this, set our application. Maybe this didn't run yet. Yeah, so we'll set up our sentence window engine, and then we'll add in the safe prompting. So here now that we're using this build sentence window engine method, adding in the safe prompting, and then we'll set up the true recorder. Now we've done so, and we can use it as a context manager, run it on the same safety or harmless test prompts that we did before, and then we can see if it does better than the first version. Awesome, so that's run, and now we can do true.get leaderboard, and here you can see we've done better in a few different things. So if we look at the violence score, our violence went down from 0.3 to just about 0. Our criminality went from 2/3 to 0. Our insensitivity went from 2/3 to 0. So we're able to clearly improve the harmlessness of our app just using that really simple safe prompt. So from there, I think we can pass back to Q&A and then kind of wrap up.
All right, super. Thank you so much for that. That was very thorough and like very cool application. Like it's just nice to see that it's actually possible to deal with all these sort of problems. Now, a couple of questions before we finish, but before we go to audience questions, I just want to talk about some of the upcoming webinars that we got. So tomorrow there's a session on designing data and AI products. So a lot of the sort of success of building AI into your application is just like, is the product actually usable? Please do come back for some design expertise tomorrow. On Thursday, we've got a session on combining large language models with knowledge graphs. So it's very important in a lot of business contexts. And then next Tuesday, there is a code along session on building a diffuser model from scratch using PyTorch. So that's getting your hands dirty with some Python, building a model for generating images. All right. So with that, I've got one question for you, and then there's a question from the audience. So I just want to know when you would have to worry about evaluating model outputs within a workflow? Like, where does it fit in? Is there something you've got to think about at the start of the project? Is it like, okay, let's put it in production, then worry about it? When do you do this?
Yeah, definitely. I'd recommend kind of as early as possible. And this, for one, is going to save you a lot of time. So rather than having to manually inspect the responses of your application and kind of, you could say, vibe check on how the application is doing, you can get that automated evaluation, and it allows you to be a lot more systematic in the way you're prototyping and improving your app. This is just going to help you get to production faster.
Okay, so you don't want to end up in production and then discover that you're
Yeah,
bots
definitely
outputting like some hateful speech or something like that. Okay.
Yeah, definitely
Earlier is
don't wait
better.
until production to do evals, for sure.
Nice. Okay. And then related to this, so Emilio's asking, how does it work in production if you need to evaluate in real time on user input? So your users are sending some information to your chatbot, could be nonsense. How do you go and evaluate what the responses are in real time?
Yeah, so there's kind of like two approaches there. In situations where you really, low latency is really important to your users, you're going to want to do more of an offline evaluation. So that's going to happen kind of in a deferred or like after the application runs. And so you'll be kind of watching the performance of your application and then identifying maybe like points of low performance. And then the other situation is more of like a high stakes situation where maybe the latency is not so important. In this case, you can do the evaluations in between, and then you can check to see how high or low the evaluation score is. And then if it passes some threshold, then you can provide it to the user. And then if not, maybe you do some sort of model refusal there.
Okay. All right. Cool. With that, we are at time. So I think we're going to wrap up there. So thank you once again, Josh. Very cool stuff. And
Thanks, Richie. It was fun.
Good. Glad you enjoyed it. And thank you to Reese moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. I hope to see you all again in future webinars.